I am Dr. Shankumar B. Patil, Professor, Saividya Institute of Technology, Bangalore. Today I am going to discuss the conversion from finite automata to regular expression. There are two methods. One is a state elimination method and a recursive method. We will discuss one by one. First one, state elimination method. For example, you can take the finite automata A0, A1, A2. So this is the eliminating state. We can eliminate all the intermediate state keeping the initial state and the final state, because finite automata consists of one initial state and minimum one final state. For example, two final states are there. One time you can eliminate the one final state and find out the regular expression, and second time eliminate the other finite automata final state, find out the regular expression. Combination of these two is a regular expression. That is, a regular expression is equal to RE1 and RE2. So this is the eliminating state. Almost all intermediate states you can eliminate. After that, only one initial state and the other one is the final state. The state which is comes before this state, we can call it as a predecessor. So the state which comes after this the intermediate state, or you can call it as a final state. So this is called as a successor. If only one predecessor and one successor is there, you can easily find out the regular expression. Sometimes we can have the n predecessor and the n successor. So in such a case, the finding the regular expression is very difficult. Okay, I'll show you how to find out the regular expression if more number of predecessors and more number of successor are there. For example, you can take the finite automata this. So the regular expression for this finite automata is after eliminating this state. So it is a 0. Then loop is there for the eliminating state. That's what it is, a star. Then afterwards 1 is there. Hence, I hope you will make out the difference between here. There is a no loop. That's what regular expression is, a 0 1. So if the loop is there, the regular expression is a star. If 1 is there, again 0 1 star 1. Okay, so this is simple. When only one predecessor and one successor is there, you will see the eliminating state which has a more number of predecessor and the more number of successor. For example, you can take this figure. So it has a, this is the eliminating state. It has a more number of predecessor and the more number of successor. So this is the eliminating state. So before eliminating state, so you need to find out the number of transitions. The transitions are one is, it is a P1. This is the transition P1 S1. P1 S1 is the one transition which is equal to A. P1 S1. So P1 and S1. So this is the P1 and S1. The transition is on symbol A. That's what P1 S1 is equal to A. Next is it is a second transition in the this figure is, it is a P1 ES1. P1E S1. So this is equal to B B E star E star C. So this is the uh, string. So in between P1 and S1. So B E star and the C. Okay. The next transition is, it is a P1. Next transition is P1 P1 SN. P1 SN. So this is equal to H. P1 SN is equal to H. P1 P1 ESN. ESN is the one more transition. You can write this is equal to B E star E star F. Okay. Like this, the next transition is, it is a PN. It is a PN PN and SN. PN SN is equal to G. So like that, you can find the some more transition. PN E SN is equal to D E star C. D E star C. Next, PN S1. PN S1 is equal to I. PN S1 is equal to I. Next, PN E SN. PN E SN D E star, it is a F. D E star F. PN E S1 is equal to D E star D E star, it is a C. P1 E SN is equal to, this is a PN E S1 SN. PN E SN is equal to D E star F. E star F. So eliminate the state E. If you eliminated the state E, P1 S1 is, it is equal to P1 S1 is equal to, it is a. Okay, it is A. If you eliminated the state E, so you can eliminate the state E. So it is a P1 S1. So already in between P1 and S1 A is there. So one more path is created. That is P1. This is the P1. This is P1. One more path is created. P1. So it is a E. So then C. P1 EC. So that is B is a B E star E star C. B E star C. Like that, you can take the PNS1. PNS1 is, so this is the PNS1. PNS1 is PNS1 SN P1 SN is equal to H. If you are eliminating state E, one more path is created between P1 and S1, that is B E star F plus B E star F. B E star F. Next, PNSN. PNSN is equal to G. If you are eliminating a state PNS1, one more path is going to create plus D E star F, E star F. Like that, PNS1, PNS1 is equal to I. So if you eliminated E, so you can get the one more path, which is transitions on D, E star C. Okay. So after eliminating state E, so these are the transitions available. One is a P1S1 and second one is the P1SN, PNSN, uh, PNSN, P1SN, so PNS1. Okay, the figure looks like this with the transition C. After eliminating state in between P1 and S1, so it is A plus BE star C, A plus BE star C. So in between P1 and SN, it is H plus BE star F. In between Pn and Sn, it is a G plus De star F, G plus De star F, and in between Pn and S1, it is a I plus De star C. Okay. So now next is any one intermediate state, so we need to eliminate because it has a the n number of predecessor and the n number of successor. It will take a lot of time to eliminate all these predecessor and the successor. So finally, if you eliminated all the predecessor and the successor, this is the figure left out. This is the figure left out. Now the regular expression for this finite automata is the language accepted by the this finite automata. The language accepted by the finite automata, we don't know what type of the language it is accepted. So, but we know the language accepted by the initial state is, so that is a set of the string accepted by the initial state. This is the initial state and this is the final state. The language accepted by this is, it is initial state of the finite automata and yes, U star. So the language accepted by the initial state is, it is R star. So initial state is accepting R star, multiple number of R, double R, triple R. So it is accepting. Okay. So it is also accepting S U star T. So it is also accepting S U star T. It is also accepting, so R star, okay, yes, U star T. Okay. So it is also accepting yes, U star T into R star. This is like a, X star, Y star, okay, and XY YX. Okay. So X star, Y star, the combinations of the X and Y, we can write it as a X plus Y whole star, X plus Y whole star. In place of the X, so you can find the R. In place of the Y, you can have the S U star T. So this is the regular expression or the language accepted by the initial state. If you are multiplying the SU star to the this, so this will be the language accepted by the this finite automata. So language accepted by this finite automata is a regular expression of this finite automata. So after eliminating, sometimes what happens, the finite automata consists of initial state is the final state. After eliminating all the intermediate state, so only initial state is left and the same state is a final state. So this is only left out. For this, the loop is a R. Okay. So for such a finite automata, the regular expression is, it is a R star. We'll see some of the example on the state elimination. So, for example, you can take this is the figure given, which consists of more number of intermediate state. So, if the more number of intermediate state is there, so it is going to occupy the more memory. So, in order to avoid this, so we are eliminating the intermediate states. So, if you eliminated the intermediate state, this is the intermediate state. The transitions are before eliminating the intermediate state. You need to find out the all the transition. The transition is a naught to a naught. It is on two. So a naught to a two it is one. Then A2 to A2 it is a 0. A naught, A1, A2 it is a 0, 2 star 0. A naught to this A naught on 0, 2 star 1. Like that, A2, A1, A2 it is a 1, 2 star 0. Then A2 to A naught it is a 2. Okay. After eliminating the state A1, that is the intermediate state, one path is already there between A0 to N, it is a 2. So one more path is created, that is A0, 2 star, and the 1. So that is a 0, 2 star, 1 is created from A0 to A0. So that's what 2 plus 0, 2 star, 1. One path is already there from A0 to A2 on 1. After eliminating this, so one more path is going to create. That is a 0, 2 star, and 0. 0, 2 star, 0. So one path is already there from A2 to A2 on 0. So after eliminating this, one more path is going to create, that is a 1, 2 star, and 0. So 1, 2 star, 0. From A2 to A0 already one path is there on the 2. After eliminating this, one more path is going to create 1, 2 star, 1. 1, it is a 1, 2 star 1. So it is 1, 2 star 1. It is not a 2 to A2 to A naught. It is a 1, 2 star 1. It is a 1, 2 star 1. It is a 1, say 1, 1, 2 star 1. It is a 1, 2 star 1. Hence, you can substitute all these values in this equation. So, in this equation, R is now it is a 2, 0, 2 star 1. S is so this is the S. So, in between A0 to A2 is a S. Initial state to the final state is a S. So, this is S. Okay, substitute S as a it is 1, 1 plus 0, 2 star 0, 0, 2 star 0, U as a, so this is the U, this is U as a 0, 1, 2 star 0, like that you can substitute the T is a 2 plus, so 2 plus, it is a 1, it is a 1, 2 star 1, 2 star 1. Okay, into S U star. So this is S. So this is S. Already S is there. So this is S. S is here. It is a value of the S is 1 plus 0, 2 star 0, 1 plus 0, 2 star 0. Like that, you can substitute U star. So this is the my U. So U is equal to 0 plus 1, 2 star 0. It's a whole star. It's whole star. So this is the regular expression of the given finite automata. The concept used is the state elimination method. So in the state elimination method, finally the equation for the regular expression is, so we had already derived this equation in the theory. So it is a R plus S U star T star S U star. Okay. So this R is a loop to the initial state. S is the path between initial state to the final state. Then U is the loop to the final state, and T is the transition between the final state to the initial state. This is the state elimination method. Next method is recursive or Leans method. So in the recursive or the Leans method, the finite automata is given. You need to find out the regular expression, equivalent regular expression of the given finite automata. So for this finite automata, the regular expression is very simple. So it is a R12 power 2. So this 1 is the base. So 1 is, it is a initial state. This is a 1. 2 is the final state. For example, the three states are there, one, two, three. One is the initial state and the three is the final state. In place of the two, three will come. Okay. Where this two and this two, this is the final state. This is the final state. Final state is a state number two. So, and this power is a number of state in the given finite automata. So, number of state in the given finite automata are two. So that's what its power is to. For example, if the finite automata consists of the three states, this power will be three. Power will be 3. So this is the regular expressions. So we need to find out the value for this regular expressions. So we need to find out the value of the this regular expression. In order to find the value of the this regular expressions, we required all the possible regular expression of the this given finite automata. Okay. So this is all the possible regular expression of the this given finite automata is. One is R11 power k, and the second one is 1 to 2. So 2 to 1 and the 2 to 2. The k value is, so always it is less than the this power, always less than this power. If it is a 2 is there, the k value is, it is a 1 is a 0, and the second one is k is equal to 1. If the power is 2, the k value is always less than this power. So if it is a 3, k value will be, the columns will be k is equal to 0, k is equal to 1, and k is equal to 2. Okay. So power is 2. That's what the only two columns we need to find out with respect to the all the regular expressions which are related to the this finite automata. So for the first column, when k is equal to 0, this is the equation is used. When k is equal to 0, so these two equations are used. So k is equal to 0, Rij power k is equal to A, where A is the transition between the state I and J, where A is the transition symbol between the state I and J. Okay. If I is not equal to j, only the transition between I and j. If I is equal to j, so for example, in the case of the 1 1, in the case of the 2 2, so I is equal to j. So in such a case, along with the transition between the I and j, so epsilon is going to come. So epsilon is going to come. Hence, if k is equal to 0, if k is greater than 0, so in such a case, we use this equation, r of ij power k is equal to, so we use this equation, r of ik k minus 1, r of kk k minus 1 star, r of kj k minus 1 plus r of ij k minus 1. We use this equation for k is greater than 0. K is equal to 0. So this is a I, this is I, and this is a j. So I is equal to j, I is equal to j. So I is 1, j is also 1. In between 1 and 1, the transition is b. In between 1 and 1, the transition is b. So I and j are similar. That's what it is, a b plus epsilon. B plus epsilon. Okay. 1 to 2. Oh, so 1 to 2 k is equal to 0. 1 to 2, it is a the transition between 1 to 2 is a 1 to 2 is a just a. 1 to 2 is a, because I and j are different. If I and j are different, so we write only if I is not equal to j, so it is a transition between the I and j. So I is 1 and j is a 2. The transition between I and j is, it is a e. It is a like that. 2 to 1. So the 2 to 1, the transition is b. I is 2 and j is 1. This is I and this is j. So I is 2 and j is 1. Hence they are different. They are not equal. Only the transition between 2 and 1 is, it is a b. Like that. So I and j values are similar, but the transition between 2 to 2 is a 2 to 2 is a. So both are similar. When k is equal to 0, both are similar. The transition between the I and j plus epsilon. This is how you can complete the first column k is equal to 0. For the second column k is equal to 1, we need to use this equation. We need to use this equation. So I am using to find out the value of the second columns, the regular expression, different regular expression when k is equal to 1. So k is equal to 1, the equation used is, this is the equation. Because k value is greater than 0, so in such a case we are using this equation. For the first case, r of 1 1 power 1. So this is r of 1 1 power 1. K value is, it is a, so r of I is 1, j is 1, k is 1. Okay, so here you can find out here r 1 1 1. So in this case, the I value is, so 1, j is 1, k is 1. So use the equation r of ik. So I value is 1, j value is 1, and k value is also 1. Wherever the I, j, k are there in the regular expression, you substitute that. R, I, k minus 1. So k minus 1 is, k is a 1, 1 minus 1 is, it is a 0. Next, R, k is 1, this k, this also 1, k minus 1, it is a 0, 0 star, according to the equation. Then R of kj, k is 1, j is 1, k is 1, j is also 1, so k minus 1, so that is a 1 minus 1, it is a 0. Okay, like that. Plus rij, I is 1, j is 1, k minus 1, that is a 1 minus 1, it is also 0. Okay, substitute the values, so you can find out all these values. So you can find out all these values from the first column. R110, so this is R110, this value is R11 power 0, this is R12 power 0, this is R13, sorry, 21, is a 2 1 power 0. So this is R22 power 0. So all these values you can find out from the first column. R110, it's a b plus epsilon. So substitute the values of the R110 from the first column. It is a b plus epsilon, R110 b plus epsilon whole star. So whole star is there. R110, it is a b plus epsilon, then b plus epsilon. Okay, so b plus epsilon into b plus epsilon star. For example, you can take so 0 into 0 star. 0 into 0 star is equal to 0 plus. So same thing, in place of the 0 we have the b plus epsilon is there, so into b plus epsilon star, you can simplify this into b plus epsilon plus. Okay, then you can take the common of the this b plus epsilon is here also is there. So here also b plus epsilon, you can take the common of the b plus epsilon. The remaining is in place of this. In the mathematics, for example, if you have a plus ab, a plus ab, if you are taking a common, in place of this, 1 will be there. Whereas in the finite automata, in place of this, if you are taking b plus epsilon common, so in place of this, in mathematics, in place of the a, 1 will come. 1 plus b. This is how we write. So here b plus e, in place of the b plus e, 1 is made as a symbol in the finite automata. So in place of the 1, the epsilon has come. Epsilon has come. If you are taking common of the, this is replaced by this. So you can take the common of this b plus epsilon and b plus epsilon. So in place of the b plus epsilon, actually 1 has to come, but 1 is made as a symbol. That's what. So epsilon. So it is a epsilon. Okay, so b plus epsilon plus epsilon. For example, 0 plus epsilon is equal to 0 star. It is equal to 0 star. Like that, in place of the 0, we have the b plus epsilon plus epsilon is there. So this you can replace it by b plus epsilon star. B plus epsilon star into b plus epsilon. So b plus epsilon star into b plus epsilon is like a 0 into 0 star. 0 into 0 star. So this is like a 0 place, b plus epsilon is there, 0 star, b plus epsilon star is there. So this you can write it as a b plus epsilon whole plus. So b plus epsilon whole plus is a, it is like a this, b plus epsilon whole plus is a b star. So the R11 power 1 is now, it is equal to b star. Like that you can simplify the R121. So this is R121. R121, I value is 1, J value is 2, K value is 1. Wherever this in the equation, I is there, you replace it by 1. I is there, you replace it by 1. So J, it is a K, K is by 1, K minus 1, 0. Like that you can substitute. See, Kj is there, K is 1, J is now 2. So Ij, so this is Ij, I is 1, J is 2, 0. Because I is equal to, from this equation, this is I, this is J, and this is K. I is equal to 1, J is equal to 2, K is equal to 1, power is K minus 1, that is a 1 minus 1, all are 0. So all these values you can get it from the first column. Again R11 power 0, b plus epsilon star, a. So you can take this, you can replace it by b plus. You can replace it by b plus. So this is what the b plus, and you can take the a common. So in place of this a, so in place of this a, epsilon is going to come. Epsilon is there. Okay, then b plus epsilon plus, so this will be b star plus epsilon. So this is a b plus epsilon plus epsilon is a, it is a b plus epsilon whole star. B plus epsilon whole star is a b star. B plus epsilon whole star is a b star, and a as it is. So R1 to 1 value is, it is a b star, J B star A, B star A. Like that you can find out the R21 values. It is a B star B. So it is a B star B. It is not a B plus. Actually, B star B is, it is equal to B plus. But we are in the finite automata. So B plus is not a finite automata. Okay, in between you can replace b star into b by b plus, but the final answer should be in the form of the star only. Star is a finite automata, it is not a finite automata. Hence, you cannot replace B star by B plus at the end. Final result should be in the form of star only. Hence, you cannot simplify this into B plus. B plus is not a finite. So only B star is a finite. Keep the D star B as it is. And the last one is this is I value is 2, I value is 2, J value is also 2, J value is 2, and K value is equal to 1. K value is a power is a K, and substitute all these values from the first column, and after simplifying, the final answer is it is a R 2 to power 1 is the answer is it is a the answer is it is a B star A plus epsilon. Okay, so once you get the values, the second column values, now you can find out this R 1 to power 2. R 1 to power 2 in the form of equation, you can write R 1 to power 1 to power 2. So I is equal to 1, j is equal to 2, and this is the k. So substitute in this equation, it is a rik k minus 1. So rik is it is a I is 1, k is 2, 2 minus 1. 2 minus 1 is 1 into the bracket r 2 to k minus 1, it is a 1 star r kj. K is 2, j is also 2, j is 2. So k minus 1, it is a 2 minus 1, it is a 1, 2 minus 1, it is a 1 plus rij. I is 1, j is 2. So 2 minus 1, it is a 1. Okay. So substitute all these values, you can get it from the second column. You can get it from the second column. So finally, you can see the R1 to power 2 is equal to R1 to power 1. R1 to power 1 is B star. R1 to power 1 is B star into A. Substitute R1 to power 1 is a B star A. Like that, R2 to power 1, 2 to power 1 is B star A plus epsilon whole star keep as it is. Then R2 to 1, it is a B star A. 2 to 1, it is a B star A. Then plus R1 to 1, R1 to 1 is it is a epsilon plus B star A. So this is the final regular expression of the given finite automata. So this we obtained by using the method called as a the recursive or lean method. Thank you.